The PD Research and Education Center's Turfgrass Pathology and Nematology program boasts nearly 2 acres of green site turfgrass within about 10 total acres of managed turf. We develop yearly and multi-year research trials to evaluate management practices that enhance turfgrass health and reduce pests, such as those of fungi, oomycetes, and nematodes. We work directly with members of the turfgrass industry, including golf, sports turf, and lawn and landscape. There are many pests that impact each of these sectors within the industry, but each also has unique needs in terms of pest management. For each of our research trials, we try to manage our turfgrass in accordance with industry standards. For projects occurring on golf course greens, we manage our greens with regular practices including mowing, cultivation, and irrigation so that recommendations arising from our projects are adaptable to practitioners throughout the state. Regardless, our program strives for effective and sustainable practices that limit turfgrass loss from disease and nematodes. Pathogens can infect all parts of a turfgrass plant. Some infect the foliage, such as the turfgrass leaves, like that of Claridia montithiana, which causes dollar spot on warm season turfgrasses. Claridia is a new genus classification for a pathogen previously named Sclerotinia homeocarpa and has different species known to infect both cool and warm season turf. Over the past year here in the PD region, Claridia has proliferated with infections ranging from golf course greens all the way to home lawns, oftentimes with increased severity in poorly fertilized turf areas. Another disease observed over the past season has been gray leaf spot, which infects St. Augustine grass, perennial ryegrass, and some fescues. Gray leaf spot has always been particularly problematic on perennial ryegrass, but recent years have brought earlier and more severe symptoms on St. Augustine grass and tall fescue grown here in the Carolinas. We have been working to better understand how new fungicides as well as biofungicides can limit foliar diseases like these during different periods of the year. By understanding how fungicides behave in relation to disease activity across the growing season, we hope to set up proper application timings that maximize efficacy while limiting the number of pesticide applications in a given year. In contrast to foliar diseases, root diseases and nematodes can be particularly devastating to turfgrass stands. This is mainly because if a root-infecting pathogen issue is left unchecked to the point that above-ground portions of the plant start to show symptoms, the root system is likely already severely compromised. This is true for nematodes, fungi, and oomycetes that grow and feed on turfgrass root systems. Nematodes such as sting, root knot, and lance have been the source of several problems this past year on both cool and warm season turfgrasses. And while we normally associate nematodes with highly managed turf areas like golf courses or sports turf, we are finding damaging pathogenic nematode populations on home lawns as well. One of the new projects that we are working on involves the use of soil amendments like composts and biochars for fostering root and overall plant development while potentially reducing problematic nematode populations. A new graduate student, Malone Thomason, began working in our lab this summer and will be focusing on damaging nematodes as he develops his thesis. Similarly, we are hopeful that we can extend this work to root-infecting fungi and oomycetes as diseases like take-all root rot, spring dead spot, and Pythium root rot are perpetual issues on Bermuda grass grown here in the state. Our program is growing here at the PD Research and Education Center, and we look forward to working with fellow turfgrass enthusiasts across the industry to help keep our grass green and pest-free in the years to come.